Okay, as I promised in the last video, which was about 5 minutes ago, I'm going to tear apart some Ubiqiti stuff. Alright, now I have fired the air conditioner up again because my office gets stupid hot. So we've got a Loco M2, a PowerBeam M5 400, or M2 400, a Bullet Titanium, ooh fancy, M2 HP, and a Rocket M5. And one last piece of equipment for you nerds out there. This Mikrotik router board RB 2011. These are all pieces of equipment that we use in the WISPs. It's very, very common equipment. Of course, there's a few WISPs out there, which shall remain unmentioned, that spend stupid amounts of money and buy really high-end quality equipment like Cisco and Cambium and that, which I'm not opposed to. It's just that the thing about a WISP is you want to try to build things on the cheap so that you can conserve money, but at the same time, you want to build things reliable and rock solid so that it doesn't go down, because you've got hundreds of people counting on you to provide them with internet. So, first things first, I've already opened this rocket up. The sticker here, you simply hit this, it's down here, you hit it with a heat gun, and it will come off. Then you take off the two little nuts on top, and I've got them right here. You just remove the rubbers carefully with tweezers, and then she opens up. Now, these guys here, I need to zoom. I need to get myself a proper camcorder, to be honest, but whatever. Okay, so let's take a close look at this. So here's our Ethernet port right here. Now these are only 100 meg ports because they're using passive PoE. So you've got pins 7 and 8 are your negative in, 24 volts typically. And pins, I believe, 1, 2, 3, 4, and 5 are your positive 24 volts in, which literally just go over here to this diode, and then into a voltage regulator, which drops it down to, well, I don't know, I think it drops it down to about 5 volts for the operation of the board. These are all Atheros-based, so this right here is the CPU. This is the memory. This is actually where everything sits, the iOS sits. I think it's like 16 megs or something like that. Right there is your transformer for isolating the port from the, well, it's pretty standard on most Ethernet equipment. It actually isolates the Ethernet port from the chipset to prevent any kind of induction that might damage it or whatnot. So yeah, let's get my little spatula here. Let's take this can apart. There we go. All right, let's get this one open too for good measure. This is not going back into production, by the way. It's effed. I mean, it died on me, and I'm just using it to cannibalize for parts to fix other ones. So realistically, I don't care what happens to it. All right. So as we mentioned, this is the Atheros CPU. It's an AR7241-AH1A, if you want to look that up. Up here is the wireless card, I guess you could say, because essentially that's what it is. You've got a self-contained Wi-Fi module in here, and it's a standard Atheros AR9280-AL1A, which I believe is the 5 gigahertz chipset. And inside here is all the workings for it, as you can see. At some point there's a, let's see here, there is some multiplexing circuitry in here. There's a couple of fuses. Yeah, they're pretty standard right across the board. Basically all this thing is just a standard Wi-Fi radio with some additional software that makes its own TDMA. It's just a driver with Ubiqiti's TDMA overlaid on it. Now, oh, here's the cool part. If you ever brick one of these guys, this header right here, this is your TTL header. They don't label them, but usually the square pin is your ground. So that's your ground right there. Or nope, sorry, I'm wrong. I always get this one wrong, it doesn't matter. I always double check before I hook my TTL adapter up. Square pin on this one is positive. The round pin is your ground because it's connected to the ground plane around it. As you can see, they left that horrible flux on there, which, as you know, I hate. And then these two pins in the center are your data pins. I believe one is data plus, one is data minus, and with that you can get this thing into recovery mode and you can upload new firmware to it if you brick it. The other cool feature about this is you can put OpenWRT onto it and you can pretty much make it do whatever you want. You can make it dance like a monkey. So, yeah. Now, these guys also have a spare socket on here. They used to come with 2 Ethernet ports, but it looks like these guys are wired to have a RJ11 jack on them, which, if you're familiar with Ubiqiti, the RJ11 on the air fibers is used for an audio tone, which you can use to aim the antenna. So that's pretty much that. I'm not going to get too in-depth with it because, you know what, I'm not going to reverse engineer it. I'm just giving you guys a basic rundown so you know what you're looking for when you get into one of these guys in case you have to fix it. So yeah, that's your typical rocket. The M2, the only difference is that with the M2 you've got the 2.4 gigahertz chip in it. With the 900, you also have a 2.4 gigahertz chip in it, but there is a down converter that makes the 2.4 function as a 900. So you're actually using a 2.4 gigahertz chipset, which goes through a down converter on the Rocket M9 to convert it into 900 megahertz. That's all. So realistically, there's only a few rockets. There's the Rocket M5, the Rocket M2. The Rocket M900 is identical to the Rocket M2 with the exception of the down converter circuitry. And then there's the Rocket M3, I believe, which is the 3 gigahertz model. Alright, so that's that. You can see the pretty little heatsink on here and the LEDs. Yeah, the LEDs you can actually see because this one here, it has a stupid design where you can't even see them properly. So that's that. That's a rocket. Alright, next, let's take apart another universal radio that we like. So, this is a titanium. Realistically, its guts are identical to a regular bullet, so don't bother wasting the money on the titanium unless you really want to have the shielding, because that's basically what you're paying for, is a nice aluminum shield. Yes, and a beautiful weather fitting on the bottom. I have to say that the hardware is way more rugged. So these guys here, you just undo the nut at the top. Pops out. That's with all bullets. Now, the bullet is a CISO radio, as you know. The rockets are MIMO. It's still a great little radio. It's really powerful. So this guy here, same kind of concept. You've got your isolating transformer here. You've got your diode down here, and your voltage regulator right there. And, yeah, some other bits and bobs. And let's rip this guy open. Here we go. So this is the CPU on it. Let's take the heatsink off because I want you guys to see it. So let's see here. There we go. I'm not going to be using this one again. It works, but I'm sparing this one for parts as well because the titaniums, there was something funny about them. I'm not too sure, but I prefer the regular bullets. So this one is using the Atheros AR7241-AH1A CPU. Actually, is that the same? It is. It's the same CPU in this one, too. And let's see what the Wi-Fi chip is. It's an AR9283AL1A. Yeah, just one number difference from the 5 gig. Alright, so there's the Wi-Fi chip there. Alright, let's see here. Multiplexer. That would be the power transistor right there. Yeah, there's your end connector fitting. It just solders right onto the board. On the back here, here's your chip, your storage chip for memory. And this guy right here, I think this is storage as well. It's a WinBond chip, which is typically a memory chip as well. But yeah, I'm not sure. This could actually end up being the RAM on here, and this could actually be the ROM. Yeah. Once again, I'm not entirely sure because I haven't bothered looking up the chip IDs on them, and I'm not an expert on chips. So, yeah, and of course you got a nice little choke coil here to filter any line noise and whatnot. So, there's the bullet titanium, M2HP. And now this guy here, it does still have a TTL header, which is right there. Typically on the bullets, they don't solder the header on. Not a big deal. You can either just steal a header from something like an old motherboard or whatever and just solder it on, or you can solder on a few leads and just plug them in, like slide them into the end of your TTL adapter. I've done that before with copper wire. That works too. You just have to be careful not to short them out. And always remember, if you're running TTL, you want to plug in your PoE, because the TTL will try to power the board, but it's not designed to power itself off of the TTL, and you can actually burn things out. This thing actually takes a half an amp to run, at least. I think actually this one, it asks for a 1 amp PoE. So yeah, you want to make sure that the PoE is connected when you run your TTL adapter. And there are some little fuses in here you can see. There's a couple of surface mount fuses, which are really handy because if something blows, typically those are them. Alright, so that's that. Let's put that aside. This guy. Yeah, these guys are disposable. You can't really fix these because once they're open, that's it. And to open it, they're glued. They're glued, yeah. So, I'll get the Dremel out and I'll do this one. Yeah. We'll skip that for now. Alright, let's open up a NanoStation Loco M2. Dirty and old. Yeah. So typically with NanoStation Locos, whether it's an M900 or these old M2s, your screw is right underneath that sticker. So typically what you want to do is you want to get a heat gun and an X-Acto knife. And we're not going to reuse this one, so I'm not even going to bother trying to save the sticker, so I'm just going to peel it off. But once again, you take your heat gun, you run it across the sticker until it gets warm, and then the sticker just peels off like nothing. Alright, here we go. We're taking the screw out. Ubiquiti, you did such a great job with these plastic overlays, except when they dried out and cracked, but at least you can see the LEDs. Now there's clippies right here, so you just need to pop it a little bit, and it should just slide right out. There you go. So there, not much of a difference from this to the NanoStation. This one seems to have some water damage in it. Actually, the LEDs look like they're all burnt. So I would assume this thing took a near hit of lightning, which would have damaged it, or maybe water got inside, shorted something out, increased the current going to the LEDs. Alright, so, bin. Yeah, okay. So, here we go. This is an M2. Atheros AR9287-BL1A for the Wi-Fi chip. And let's see what the CPU is. That's my horrible cell phone, sorry. Alright. AR7241AH1A, the common Ubiquiti CPU. Alright, now the beautiful thing is over here is your header for your TTL. And as you can see, it's really nice. You've actually got a lot of stuff to work with here, but you're only going to use 4 pins, right? Pardon me one moment. That extremely important phone call was my other half wanting me to pick up vodka for tonight, so I'm probably going to pick up some vodka for him and some cherry brandy for myself because I'm sick and cherry brandy is good for you. Okay, so back to it. So I was just telling you that this is the Atheros AR9287-BL1A Wi-Fi chip. There's the oscillator there. There are a couple of little external antenna headers because this is MIMO. So you've actually got 2 connections for the antennas. Standard Atheros chip. There's your diode. Comes off of the Ethernet port to power the circuit. Let's see here. Your little transformer, memory, and more memory, and choke inductor. There's inductors all over this thing. I mean, because of course it's going to take a lot of damage and storms and that. And surprisingly, Ubiquiti actually holds up pretty good, knock on wood, to close discharge or ESD and that sort of stuff for lightning. Now, here's the antenna array. This is actually, let me just take the screws out of this for you. Alright, cool. There we go. These are really built well. I have to say that. I mean, Ubiquiti's engineers did an amazing job when it came to designing and building these things. The software, on the other hand, it can be flaky at times, but you know what? Once you get used to managing a network full of Ubiquiti equipment, which we do, you learn that there's all sorts of ways to make it work really, really well. Alright, there we go. I've got these awesome little plastic nuts off. I'm just going to let the component... There we go. Okay. So, this is the projection element. This is the one that actually sits at the front here. And this element is where you get your horizontal and vertical coming in from the board. There's your two antenna leads, and then this is your central ground in the center. If you want me to get into radio energy physics, I'm not going to do it right now. Talk to a ham radio nerd anyway. But yeah, so this just passively sits in the front here, like that. And the energy is focused. This is almost like a small waveguide. These are actually good for, I think, correct me if I'm wrong, 60-degree beam width. So yeah, this little guy just sits right here. The energy projects. This guides the energy in 60 degrees, and yeah, that's all there is to it. So as you can see, it's a very simple design. And yes, these things are very reliable. They work really well. It's only software that ever causes problems with these Ubiquiti devices. But you know what? AirOS is sick. I mean, it's awesome, especially with the TDMA. It really allows you to run a lot of devices on it. Okay, I'm going to crack this thing open. Maybe literally. There we go. As I said, there is no fixing these guys unless you can get a solvent that will dissolve the PVC glue around here and allow you to put it back together when you're done, which I haven't bothered trying, and whatever. This one's screwed. It's an NFG. So, yeah. Okay, so here we go. Here's your reflector. So when the feed horn is mounted into the dish, the energy comes off of the little elements right there. Hit these, and these guide it into the dish, and then it reflects from the dish into your beam. That's all there is to it, and vice versa. The dish picks up energy and focuses it in here, and this concentrates it into the elements inside of here. And I believe this is glued in slightly, so I'm going to have to yank it out. There we go. There's that. This is your empty shell. Garbage now. Alright, so the PowerBeam M5 and the PowerBeam M2 are fairly similar in design, except, of course, the elements are going to be smaller on the M5 because I can't remember if these are quarter wave or what. They might be half wave. 2.4 is pretty small. But yeah, so there's your elements. I believe this is your backplane here. This is your grounded elements, which are your backplane. They line up perfectly. So this is vertical. This is horizontal. You can, if you look closely, this is in 1080p, so you should be able to see that. You can see itty bitty traces here. See those? That trace right there is your horizontal, and this is your vertical, or vice versa, depending on how you polarize the dish, which some people have managed to hack them and put them sideways, because actually if you slant them at 45 degrees, you get cleaner signals. There's not much on that band. So now, let's take a close look at the chips and stuff. So this is much newer, e-tron tech. So that's the RAM right there. And the MXG chip, is it MXG? I can't read that. MXIC, I believe, is what it says. That would be the ROM chip right there where AirOS sits. Now, I do believe that these guys here, please correct me if I'm starting to sound like the guys who I'm watching on YouTube. I think this Atheros chip is an all-in-one. It's an AR9342-BL1A. I believe this is an all-in-one CPU and Wi-Fi chip. Alright, and then, yeah, there's your choke, there's your transformer, voltage regulator, all sorts of fun stuff on here. The Ethernet ports are handy for things on these guys. They're probably the only part that you can really salvage. There's fuses everywhere on these little guys, which is awesome if you could put them back together. And I would love to be able to open these guys up and put them back together. But yeah, that's basically, they've made these very, very simple. So this is why they can mass produce them as cheaply as they do and pump out a really awesome product that, you know, it's just simple. And it's made with really good quality components. So yeah, there's that one. So now we've got that open. Alright, so our pile of Ubiqiti equipment is growing. Now, ha ha ha, for all the other Wisp nerds out there, this is, I've already scavenged the LCD, sorry. This is a router board, RB2011 UIAS-IN router. And these things are amazing. This is made by Mikrotik, and they're very powerful, and for the price, you're getting something which does pretty much what any Cisco or HP or any other major brand name router will do. It'll actually do every single thing and more that a router's typically capable of doing. Yeah, it's got a console port on the back, 10 to 28 volts DC input on the board here. These are all 100 meg Ethernet ports with 1 power over Ethernet output. These are all gigabit Ethernet with a PoE input and an SFP, so you can plug in a fiber converter, and you can, you know, you can put this at the end of a long fiber run and use it as your bridge between sites. This model can also come with Wi-Fi built into it, which is really handy. And let's open it up. Oh, sorry, it's got USB on the front of it, which is, I haven't really found a use for it yet, but maybe Mikrotik Tech can tell me what it's good for. Okay, so now, I'm pretty sure this is all Atheros too, because Atheros make awesome chips. What the hell did I do with my spatula? Ah, well, you know, I don't really need it. Okay, I'll use my spudger. Okay, so, yeah. This would be the gigabit side right here. This is the 100 meg side right here. You've got your RAM right there. Or, yeah, this would be the RAM. This is the ROM. Yeah, this is where the Wi-Fi circuitry goes on it. Let's see. So this, yes, it's Atheros. An Atheros AR trying to read it. Ah, hold on. We're gonna need to clean that a little bit. Where's my alcohol? Where's my alcohol? I need to get drunk. No, I'm just kidding. Alright. Let's get that glue off of it. Okay, so it's an Atheros AR9344-DC3A. I believe that is the CPU for the whole unit. And then this little guy over here is another Atheros. It's an Atheros AR. God, why do they make these things so difficult to read? AR8377-BL1A. Wait, didn't I already see one of those? I think I saw... No. No. Huh. Oh well. Either way, it's another Atheros product. They make some awesome stuff, as you can see. This is all that there is to it, really. These little routers are really powerful, and you can do a hell of a lot with them. Don't reflash them with other firmware. Use the Mikrotik firmware because it's really loaded with features, including a sick firewall. It's got awesome VPN capability. Yeah, you can even use OpenVPN on these things. They're great. Here's your power port. This is basically a power circuit in here. You've got your full wave bridge rectifiers right here. This little guy here is a transformer, I believe, for the PoE port, the PoE in port right here. It's kind of off on its own. This is a combined transformer for all these ones here. That one's for these ones. Got some caps in here to clean it up. A couple of inductors, your oscillator. Yeah, that's pretty much all there is to it. And there's your port for your LCD. And it's your JTAG right there. So, yeah, these guys are really awesome. This is all the equipment that we typically use on our network, is Mikrotik and Ubiqiti for the most part. And I plan on making another video discussing backhaul equipment, like Cambium versus Mimosa versus Mikrotik versus Ubiqiti. But yeah, I figured I'd make a quick little video and show you guys what was in some of this equipment. Yeah, so, yeah. Here we go. Put it all back out here. Let's, a few pieces of equipment from Ubiqiti. Really, really nice stuff. Big fan of it, and if it wasn't for Ubiqiti, we wouldn't have a network, and we wouldn't have over 600 customers currently. So, yeah, there you go. That's all there is to it. Well, thanks for watching. I hope you guys enjoyed the video, and yeah, I'm going to try to make more and more regularly. If you have any suggestions of stuff that you'd like to see, send me a message or put it in the comments. Thank you. We'll catch ya.